Good afternoon, everybody. This is the second presentation about excavators. Today we'll be covering loaders and some secondary types of excavators. So, from the shape, you could see that loaders they typically work on the level with relatively smaller heights than the ranges of front shovels and smaller depths than the ranges that backhoes could reach. However, they are much more mobile. They could easily carry a load and move with it. So they are much more mobile than backhoes and front shovels. So there is a variable element of cycle time when we will be discussing the cycle time, which is the travel time. So typically loaders are either wheel loaders or crawler loaders, track loaders. So they are either wheel mounted or track mounted. And as any piece of equipment, track mounted equipment are slower. However, so they could reach lower speeds when compared to wheel mounted equipment. However, they could apply a larger force. So the load that the loader could apply while excavating in the soil itself, in case of a track mounted loader, it's higher than that of a wheel mounted loader. So if you pick maybe the 2 cubic yards from both and compare, you'll see that the static tipping load is significantly larger in case of the track loader. However, the maximum speeds are much less. So, like anything in life, you will never take anything. You will sacrifice one thing for the other. So the bucket fill factor, again, the same concept of the bucket fill factor that we applied before with front shovels and backhoes could apply with loaders. So the bucket fill factor, again, it changes depending on the material. And it slightly changes depending on whether it's wheel or track mounted loader. Again, you have, but the major difference between the loader and the other excavators that we discussed before is that in these excavators the cycle time was nearly fixed. However, here there are fixed components of the cycle time and variable components. The fixed cycle time is mainly for loading, maneuvering, reversing directions, and dumping. However, the variable cycle times, it depends on the distance. So the larger is the distance, the more is the variable cycle time. And again, like what we mentioned before, for scrapers, in chapter 6 we're discussing mobile equipment power requirements, you will have either tables or charts that will give you the speed, and when you use the distance with the speed together, distance over speed, you will be able to get your time hauling and returning again. So this is very simple and you should be aware of it by now. So let's take a very nice example. We have a 4 cubic yard wheel loader that will be used to load trucks from a quarry stockpile at processed aggregate having a maximum size of 1 1/4 inch. The whole distance will be negligible. The aggregate has a loose unit weight of 3,100 pound per cubic yard. Estimate the loader production in tons based on a 50-minute hour efficiency factor. Use a conservative fill factor. Of course, here he's requiring the loader production in tons because this is a quarry. In a quarry, you are dealing with material that you will be selling in units of weight. So you need to get your productivity in units of weight. So first thing, we have the size of the bucket. Then the first thing that you should always start with when dealing with a loader or a backhoe, specifically these two, is to check that it could do the job actually. It is safe to do the job. So in such a case, you should check the static tipping load. So here I know that my bucket size is 4 cubic yards. The bucket fill factor will range between 85 to 90%. So I'll use 85% to be conservative. So this will give us the load weight. The load is 3.4 LCY. So this weight is equal. The weight will be 3.4 times 3100. So this is 10.54 kips. So if we go back to the tables, we'll find that the static tipping load is 25,000. So the operating load should be safely, you should always have a factor of safety. So the operating load is safely taken as 50% of static tipping load. Okay, so 50% of 2500, this is 25,000, this is 12,500. So this is for sure larger than the actual load, so therefore it's okay to use this size. However, you should be very aware that this thing is a little bit critical, because if you don't, if it is unsafe to use it, then you should change the size. So if it is unsafe to use it, you should get a larger one to do the job, even if this will be on the account of your pocket. Okay, because safety comes always first. So typical fixed cycle time for from the table 9.1 4 cubic wheel loader, so it's 30 to 33 seconds. So here he used 30 seconds, and for sure I am in disagreement with him. He should be conservative and use the 33, because this should be a conservative estimate to increase the cycle time, not to decrease the cycle time. So when we say the word conservative, you should look at whatever in the numerator of the equation and decrease it, and to whatever in the denominator of the equation and increase it, in order to minimize the value that you will be getting to be the most conservative value ever. So the efficiency factor is 50 minute-hour. The class of materials, the aggregate is 3100 pound per LCY. So now we'll apply the numbers: 3600 second per hour times 4 times 0.85 times 50 over 60 divided by 30 seconds cycle times 3100 pound per LCY divided by 2000 pound per ton, which is the conversion factor between the pound and ton, because we need the productivity in ton per hour. So this will give us 527 tons per hour. Uh, so now we could move on to specialty excavators. Specialty excavators, for example, are trenchers. This is the most common specialty excavators. You have what you call the wheel trencher. This is very similar to the water wheel, actually. So this cuts into the soil by these edges, and then it moves the spoil up here, and a conveyor belt transfers it to the back. Very similar to it is the chain trencher, which is very similar to a chainsaw, the electric saw. So but it's having the same concept as the wheel trencher, but it could reach deeper locations. Again, you have a micro trencher. It's the same concept of the wheel trencher, but on a smaller scale. And you have a portable trencher, which is the same concept of the chain trencher, but on a smaller scale.